Thank you for attending. My name is Ka-Chun. I'm currently a senior developer in the Db2 utilities team for zOS. Probably been working there for like 15 years now. And I'm also the owner of the Reorg utility and also work with other data manipulative utilities like load, run, set, and so forth. So chances are if you have opened a PM hours against the Reorg utility in the past, I have probably been part of it and caused some PEs on your shop and so forth. So over the next hour or so, we'll talk about the Db2 Reorg utility and kind of in general also about the reorganization, the whole concept of reorganization. For some of you, this is probably the most relevant part of your job, day-to-day job, and for some of you, this is probably your most hated topic that you need to deal with also. So having said that, the usual disclaimer and such. So here's the agenda. So for the first part, I'm going to just spend a few minutes talking about the overall reorganization process. Most of you probably have knowledge and history on this already, so I'm not going to spend a lot of time, but I just want to highlight some of the relevant points related to Db2 utilities and others. And then we're going to talk about the evolving goals of reorganization. Since I started working in the company 15 years ago, the reorganization landscape, the requirement, the reason you want to perform data reorganization is significantly different from what it is now. So I think the landscape has changed, so it will be a good idea to for us to reveal why do you even need to reorg nowadays. And then having gone through that, we're going to talk about some of the biggest challenges you deal with every day. For sure, I know coming in, working on PM hours and surface work, what kind of issues that you see day to day. So I want to discuss some of those challenges and also spend a few minutes to talk about some of the best practices. Solutions that we have in place to kind of adjust some of your pain points in the area. And last but not least, what is going to happen next, right? All of you know that we are now in Db2, we are going for continuous delivery. We no longer have a release boundary. What does it mean for utilities development? What does it mean for new function enablement and so forth? So we are going to spend just a few minutes to talk about the summary and also the future directions. Okay, overview of the reorganization process. So this is just vanilla basics. So our Db2 Reorg utility for zOS is what we consider an online utility. In order for you to run it, the Db2 subsystem must be up. In the past, there are tools or vendor products that can operate directly on the recent dataset outside of Db2, but such is not the case for our Db2. For better or worse, our Db2 Reorg utility code path actually go for some of the same code path that you would have executed for query and DML for the Db2 engine, data manager, index manager, buffer manager. So that's how we architected that we are actually part of the Db2 family. Most of you know that we often kind of do address spaces. When you submit a JCL job, MVS will create a batch utility address space. And then we also operate on the DBM1 address space of Db2. So the reason I bring this up is that in the past, we have a lot of maintenance-related issues that you experience because you have mismatched DBM1 and batch address space changes. So those are some of the uncommon things that we need to watch out for. And also, in the past, there are a lot of confusion about Db2 LUW reorg and Db2 zOS reorg. For the most part, all of our Db2C reorg utility is shadow utility, meaning that it uses shadow technology with shadow data sets to perform the reorganization into. This is different from LUW where they have in-place reorg, where if you think about it, it's like your Windows operating system. When you need to defragment a disk, they just kind of do it within your C drive. This is different. We are actually cloning the object into a separate recent data set and then perform data set switching to complete the reorganization. So we will kind of review some of the advantages of doing that and also some of the challenges because of it. And since Db2 version 8, we only limited the sort program to two choices. You can either have df sort or we have a separate license charge product Db2 sort that performs sorting. And we'll go for the details in a bit more, but for most of the sorting for the reorg utility, it's only limited to reorg table space. Index reorg and log reorg do not involve any sorting. And last but not least, in the past, I think 5-6 years, we have really been beefed up on the SIP offload capability of our utility processing. So for the majority, if you're up to date in release or current maintenance, the majority of the reorg processing now is still offload eligible. So we'll go through that in a little bit of details later on also. Okay, I used up all my diagrams on the next couple of slides. So this is just all graphic. So this is just a very high-level kind of flow of our reorg tablespace utility. Typically, you will have a source tablespace or index, which will unload the data from, perform sorting of the data records into clustering order, and then reload it back. Depending on the share level that you specify, we either reload to the original data set or shadow data set. And then while we are reloading data, we extract the keys, put it into index sort, and then build the index keys into the index data set. And then when you're running a server change, which I believe is probably 99% of everyday users, we'll also catch up with the concurrent changes with the log apply phase, followed by the switch phase to actually logically switch the data set between the original and the shadow, and then complete the utility. So that's just a high-level eye chart about how our main reorg utility works on the table space. And for the chart up here, I just kind of briefly describe what are the concurrency, availability implication when you're running a reorg utility. Nowadays, not many people want to server none. Server none means that the utility has complete control of the data set from start to end. Nobody can update it. Because of availability, hardly anybody is running that nowadays. Most of the people run with either reference or change and predominantly change, where we have pretty much read-write access on the target objects throughout the reorg utility execution, except for the brief window during the log and the switch phase, where we all need to quiesce everybody and perform the data set switching. So that's the overall reorg table space execution. Now, lob is a completely different species in terms of the code path taken underneath. For the most part, we still have shadow data set and log phase and switch phase. But we only have a single phase where we extract the log from the original table space, log table space, and copy it into the shadow log table space. And this is combined to be a log phase. The only really thing I want to point out here is that we no longer support server none, I think ever since Db2 version 10. That is really our only flavor of in-place reorg that we had in Db2C utility, and we have even deprecated that. The reason is that we found a lot of challenges trying to do a reorganization in place. It doesn't really reclaim any free space. A lot of times it failed because we run out of space to accumulate the data movement and so forth. So for the most part now, starting in version 10, we always recommend a server change reorg whenever possible. And last but not least, reorg index. The only thing I really want to mention here is that when you reorg the table space, the indexes also get rebuilt. So there's really no reason for you to run a separate reorg index after running a reorg table space. But if there is a need for you to run reorg index, the underlying technology is pretty similar. The only thing I want to note is that we don't sort the index keys. Everything we do is relying on unloading from the original index in key order, and then reload the keys back in key sequence afterward. So we'll also talk about some of the challenges of such a utility in a later slide. Okay, so that's just a 5 minutes high-level background of how our reorg utility operates in Db2C. Now, the reasons for reorganization. So when I started, all the reasons for reorganization is about performance. The table space got updated, inserted frequently, or the index, things got out of order. Most of the customers have weekend jobs to go for objects and reorganize them. In order to do what? In order to reclaim the free space, get rid of any indirect pointer overflow relationship such that they can maintain the application performance level when doing access on the object. Clustering is also very important if you have range predicate queries. On the other hand, if you ever do a singleton probe into the index to get the data, then clustering is not very important. So here are some of the reasons, historically, why we perform reorg. Basically to reclaim free space and to ensure the application performance is on par after a lot of SQL has gone into a modified object. And then there are also other functional reasons like compression dictionary. Before version 9, the only means for you to build a compression dictionary is via either the load or the reord utility. So for existing object, if your compression ratio start to degrade over time because you have made updates to it, you have to do some schema changes to it, add a new column and so forth, you will typically want the reord utility to rebuild the dictionary. And then still one of the more frequent usage is for this discard criteria. So the reord utility support discarding. You can specify a discard when you give it a criteria. A lot of the users choose to do this because compared to SQL delete, unless you're doing a mass delete. Otherwise, if you're doing singleton delete for SQL, everything is logged and performance is not that great. So a lot of times, if they need to discard some records based on time criteria or something that is tangible, then they can run the reord discard, run the reord tablespace utility with discard so that we can just discard the records as we unload the records, and those will never make it back into shadow after we are completed. So those are some of the existing reasons. But since then, starting I think around version 9, 10 timeframe and continuous onward, everybody in DB2 try to put me out of a job very heavily right now. They come up with topics to avoid reord, right? Things like disorganization. Basically, the message is that they want to better handle disorganization in the engine itself. So in version 10 timeframe, I think they come up with index leaf page list prefetch. They come up with an asymmetric split of an index leaf page. So all this is trying to balance out your workload to maintain a satisfactory performance when you're trying to access the object, even though it has been updated and accessed over time. And then as far as cleanup, I mean, we talk about cleaning up the holes on your index or your table space, sudo delete the keys, sudo delete the record, and so forth. Now DB2 have built-in system agent to go through and clean up some of those holes to free up the space for your next use of your DML. So cleanup has been part of it. % free for updates, so be more intelligent about reserving free space for your SQL or your DML update operations. Compression on inserts, another new thing, right? In version 10, I believe. Yeah. We allow, instead of relying on load or reord to build a dictionary, now if you're using SQL insert and insert a significant amount of data into a table space or partition, it will trigger off compression dictionary build on the fly without your interaction. So those are some of the things we have done in the engine itself to avoid the need for reord. Or I shouldn't say avoid the need, but at least to reduce your frequency to run the reord utility. And also, over the years, we have also delivered other functionalities that you can think about whether it can be used to replace, that can be used to avoid running reord also. For example, when you create a brand new non-unique index, in the past, you need to run the rebuild index utility on it. But then you'll put the table space in the read only while the rebuild is happening, so that's no good. So in that times, a lot of people choose to do a reord of the entire table space with several change in order to rebuild the index. And then we come up with rebuild index several change so that you can rebuild the index, the non-unique index on the fly while you have application availability on the data itself. So that kind of take away some of your reord need. Low replace server reference is another one. I'm aware of some users who have like a PBR or partition by range table space where they need to cycle through partitions. So in the past, they need to run the reord utility to kind of reorganize the empty partition to bring it back to the primary quantities amount in order for it to grow afterward. And before, they didn't want to run low replace or reord server none because if anything is to happen during the utility processing, it will leave the partitioning recover pending. And if that is to happen, that becomes outage and so forth. So we introduced low replace server reference in version 11, so that will provide you another means to empty a partition without necessarily impacting and causing it to be recovered. And talking for a lot of customers, they still have a lot of challenges performing reorganization. So a lot of them come up with some ingenious way to perform a reord without actually performing a reord. For example, by using replication. They would try to replicate to a different DB2 system or different DB2 object, and then go for rename processing and such to kind of switch the different objects logically. So I mean, over the years, there are different techniques that people have been doing to avoid running the reorg for one way or another, and these are just some of the examples that I want to highlight. Now, so as I mentioned, so the historical need to perform reorg because to regain clustering, to regain free space, those have been gradually alleviated or reduced. But since version 10 timeframe, reorg really has taken a new life as something else, as a new function enabler in DB2. So for those of you in the audience, you're probably very familiar with some of this: reorder row format, inline lob, hash tablespace, UTS. A lot of these are new functions we introduced in the DB2 engine. But the problem is, it's fine for a user to create a brand new object with those attributes. But how do you get a existing object, existing populated large table space to use the functionality without incurring an outage? The good old concept where you need to unload the table space, drop, redefine with a new attribute, and then reload, that's a very painful process involving hours of outage. So over the years, the reorg table space in particular, servo change, has been exploited as an agent of change to enable you to transition from your old state to a new function without incurring a significant outage. So we find new life in the reorg utility enable new function in DB2. And that's not only it, right? So to me, reorg is a lot like moving houses, or I tell my kids to clean up the room. So a lot of times you just don't want to move everything back to the same room or same space, right? There are things you want to do to it. You want to repartition the layout, you want to extend the room or something, right? So a lot of these schema changes, you can't really do with an in-place reorg, but you can do when you have a shadow technology where your original table space and your shadow table space can be completely different. So we kind of explore a lot of that concept in terms of online schema changes. So for example, UTS conversion, being able to convert a non-partition table space to a PVG with multiple partitions. So those can be done logically at the data level as long as we have two disjoint different definitions between the original and the target table space. So that's what Reorg has been using as an agent of change to perform UTS conversion. And the other column attributes, right? Altering the limit key boundary, changing a data type from char to varchar, things that used to maybe put your object into rebuild pending or cause your index to be going rebuild pending. Those have been converted to what we call a pending outer, so that you issue an outer statement, the outer actually don't happen, it got cached away, and the next reorder that comes along will pick up the outer and perform the change as part of the reorganization. So Reorg has become a really powerful tool for you to remap your data into different containers, if you think about it logically, right? You can transform the data as you move it. You can change the shape of your container when you perform the reorganization. So that's why Reorg has been a pretty powerful utility to be able to materialize all these schema changes. And I didn't exhaustively list everything here. I think this is some of the big, major ones we did up to version 12. And then we have a whole laundry list of requirements from converting between PBR and PVG, from changing the partitioning column definition, and all those stuff that can be potentially be done by the reorg materialization. Okay, so kind of mentioned already. So the historical need for routine reorgs, where you just schedule jobs over the weekend to run on the table space, because for better or worse, you don't know if a reorg is needed, but you have always been doing it. Those kind of reorg has been going away. And a lot of the new tools now, toolings and statistics, is getting sophisticated so they can help you to determine whether it's necessary to perform the reorganization or not. DB2 is getting smarter. Hardware is getting better and better in terms of solid-state device and flash copy usage. So a lot of those factor into tolerating your disorganization and making the frequency of reorg even lower compared to before. But a lot of you, I think, still, I mean, honestly speaking, right? This is not a human's job. consider a large sort with hundreds and thousands of objects, you can't really keep track which object to perform the reorder and which way. So somehow down the road, toolings and procedures has to be in place for you to maintain your objects over time. And I think for the majority of us, we are still running reorg routinely because, for better or worse, we don't know whether it's necessary. For small table spaces, that's generally not a problem. You can run for the reorg over weekend whenever it's really quick. You run for a couple hours maybe. The challenges that we'll go for later is that when you have large objects, table spaces with thousands of partitions, terabytes of data, those are the type of reorg that you cannot just run it and expect it to finish without some kind of tuning and capacity planning. So we'll go for some of the challenges down the road. On the other hand, the need for planned reorgs is going to increase. What I mean by planned is that something you do, you knowingly do. Schema changes. You want to convert a table space to UTS. You want to drop a column, add a column, and so forth. So for those schema changes type that you plan ahead and perform the reorg, I think those need is going to continue to increase. Okay? So challenges and best practices. So as I mentioned, our Db2 reorg utility uses shadow technologies. And for the most part, I think it's the right strategy, and it has a lot of advantages. For example, if something is to go south, if something went wrong with the reorg processing, because, for example, you run out of space in sort work or something, for the most part, you can just terminate the reorg utility and then proceed forward. We wouldn't be leaving your objects in any broken status. There wouldn't be restricted status of reorg pending or recover pending that would impede your object's availability. And also schema independence, right? Like I said, when you have a shadow, they can be completely different, kind of like temporal and system version in the table, right? Your source and the target can be completely different, and that gives us a lot of leverage in terms of materializing some of these schema changes. But on the flip side, over the years of all the PMLs I have been working on, I mean, there are common trends of the pain and the challenges that you all face with. So those are the three top ones that I can think out of the top of my head. So density requirement, obviously with shadow, density is needed. MPI, I don't know how many hours we lost on sleep dealing with MPI on a powerful reorg execution. So that has been a challenge. And also, in order for your shadow reorg to be successful, it has to be able to break in. It has to be able to complete the switch. So to tune your reorg in such a way that you can break in successfully, that has also been a challenge over the years. So the next few slides, I'm going to go through some of these three main topics a little bit more. So that's the requirement. So I'm talking about the worst case scenario here. And typically, I'm talking about reorg table space shuffle change job, which is, I think, the prevalent variety that you're running out there. So first of all, we need the density for the shadow data sets. You can't avoid it. You have to be able to have all get organized in the shadow data set. And then you think about it now, when you sort the data, we also need software data set to hold the data, to hold the index keys being sorted. So that's another set of data set. Image copy, it is required when you're running an online reorg utility. So that's kind of like the first set of data that you need to allocate. And work data set in the past, we need to allocate like temporary work data sets, sysut1, sysret to kind of hold the data in transition, like between the reload and between the index key build. That, at least that part of it has kind of gone away with more sophisticated in-memory algorithm and piping and so forth. But I mean, we are still talking about in the worst case scenario, right? I mean, you talk about at least 3x, 4x of your existing data set size. And if you think about if you are dealing with a compression, if somehow we need to decompress the data records, when we unload the data, we are even talking about even more density, more resource consumption compared to your existing table space size. So here are some of the things I want to highlight. Like I said, density for shadows, you can't avoid it. But one thing you can do is to make sure that you allocate the intelligent primary, secondary quantity to it so that we don't over-allocate and waste space unnecessarily. So for the sorting, the index sort cannot be avoided. We experimented with a different algorithm where we just kind of build the keys into the shadow index without sorting the keys. But you know that by random I/O, when you're processing keys in completely non-key order, that kills the performance of reorg. So index will be always sorting the keys. However, for the data sort, that's another question, right? When you reorg table space, we sort the data typically by the clustering key order. So that becomes a question to you, whether clustering is important to you or not. Do you really have any range predicate queries on the table, or you're doing predominantly probe processing to index probe to retrieve your data? If your data is not really sensitive to clustering, then please don't sort it into clustering order. Right? You're just kind of wasting resources to put it into an order that you don't really need. So to avoid the data sort, there's a keyword sort data node that you can exploit to tell reorg just to unload the data with a tablespace scan, and we'll just reload it back in. That also works well for the case when clustering is important to you, but you know the tablespace is already clustered. But you are reorganizing it for a different reason, like changing like DSIs, things like that, right? Things that are logical changes that wouldn't affect your data order, but you can just use sort data node still to preserve the existing clustering order without degrading it. And the other thing I like to do, use keep dictionary. A lot of people think that when you specify keep dictionary, that just tell reorg to avoid the old processing cost to decompress and rebuild the compression dictionary. Actually, it's more than that. When we are building a new dictionary, we actually need to decompress your record into whatever the expanded format, sort all those records, and then reload it back into the shadow data set. So if you talk about a record that used to be 80% compressed, your 200 bytes record now becomes 1,000 bytes. And all those 1,000 bytes needs to be sorted, need to pass through memory, piping, and so forth. So that's a lot of CPU overhead for processing long records. So unless you really need to rebuild a dictionary, best practices is to use keep dictionary. Image copy, again, is required because otherwise your object becomes non-recoverable after the reorg finished. Due to space concern, and as many of you know, you tend to allocate image copies to tape. A lot of you do it. We support it. Just keep in mind that over the years, I see a lot of performance issue with tape in image copies, and has to particularly deal with the closing of the tape image copy data set. Because somehow if your tape, especially if you're using tape stacking, things need to be rewinded and so forth, that kind of adds to the closing time where the reorg is holding during all exclusive access on objects. So if you can afford DASD as for your image copy, you can always roll the DASD image copy to tape after the reorg finishes. But DASD generally performs better than tape. And as I said, all those word data sets now that we used to use to hold the transition between the records and the keys can be avoided by doing things in memory and parallelism. So sort def, no stress, sort key specification, those should always be used. So that's the end of DASD. Now MPI. So I think it was version 9 when we decided we need to get rid of that build-to phase, if any of you remember what that is. So when you want a part level reorg, what we do now is that we actually shadow the entire MPI. You can have a 10 parts table space, you reorg only one part of it, part 1, but we need to construct and shadow the entire MPI holding keys for all 10 partitions. So that we can switch the data set along, just like the table partition, without incurring the outage, update the key in the MPI afterward, what we used to do in the build-to phase. Now, in order to do that, we actually need to construct the MPI from 2 sources. So for using the example where you have a 10-part table space and reorganizing part 1, for the part 1 keys of the MPI, we extract that from the data records that we are reorganizing. So those keys will be sorted and so forth. For the other partitions, we actually need to unload them from the original MPI. So we need to do an index scan for the entire MPI and unloading all those keys belonging to partitions that you're not reorganizing. So there are 2 pieces to it. We tend to load the index keys from the part that are not being reorganized, and then insert the keys from the partitions that are being reorganized. So first of all, if your original MPI is disorganized, it can potentially affect a long time for us to do the key scan to search for the index keys. And then if you think about it, the more data that you're reorganizing, for example, if you're doing a part range reorg and you're reorganizing 90% of your data, that means that for the 90% of the MPI keys, we are doing singleton insert into the index, which is a lot more expensive and inefficient. So customers always hate this when I tell you, the best reorg to run, if you can afford it, is always to do a whole tablespace reorg. Then you will never get into this whole mess about how the MPI is being built and whether that has been optimally built or not. But due to, for example, density reason or the resource consumptions, you cannot afford a whole tablespace reorg, and we understand that. So for that case, at least I ask you not to run part level single part reorg one at a time serially. Try to group, based on your capacity, try to reorganize as many partitions as you can in a single reorg job. So for two reasons, right? One is that, part level reorg, even without MPI, a single reorg job is still potentially more efficient in terms of all the processing overhead compared to running part level reorg one at a time. And second of all, each part level reorg is going to rebuild the entire MPI. So the less number of part level jobs you run, the less number of times MPI is being rebuilt. So that kind of saves your overhead processing on the MPI. So somewhere along the line, I think it was in 11 or 11 retrofit bracket 10, we come up with this part option. So you can tell reorg, okay, if you're giving us 10 partitions to reorg in a list, reorganizing n partitions at a time to kind of strike a balance between how much resources being taken to the number of reorgs that you're running. And the other major consideration is really this sort MPSI. So the problem with, we have some, when in the past, when user is doing a large reorg, meaning a part level reorg, but reorganizing a large amount of data, the performance is horrible in the sort build phase because we are doing singleton insert into the shadow MPI for all the keys for the rows that are being reorged. So we come up with this idea, okay, so ideally, if you sort all the MPI keys together, both from the partitions that you're reorganizing and those that are not, sort everything and then just load it into the index. Performance on the index build will be great because everything is done in key order from 1 to n. So that's why I come up with this cPan also keyword to give you an option to say, okay, what do you want us to do? Do you want us to pay the overhead cost of inserting into the index, the shadow index, or you want us to just sort all the keys? Obviously, there's a trade-off, right? If you choose to sort all the keys, again, you need to have more sort work data set and all the allocation, all the resource consumption for the sorting. And then you need to balance it out by the number of keys that you're being inserted. So it's kind of like a seesaw between how much data is being reorganized and how many MPIs and so forth. So generally speaking, the more data you reorganize, it's better to sort the MPI keys, all of them. On the other hand, if you're only doing a reorg on an empty partition just to reclaim space, that's possibly the worst scenario where you are rebuilding an entire MPI one key at a time when you should have just sort all the MPI keys to begin with. So our recommendation is to set it to auto. Basically, the reorg has some intelligence internally based on internal threshold, how many MPIs there are in the table space, how much percentage of the data you're reorganizing, and use that to kind of determine whether it's better for you to sort the keys or not. So we have the intelligence to kind of at least do some calculation based on that. So as I mentioned, a lot of times, especially if we're reorganizing 80% of your data already, of the partition table space, it might be better for you to just reorg the entire table space. And also, customers don't want me to mention this, but a lot of times, do you really need to MPI? I mean, there's definitely a usage for it. We introduced dipsy back in Db2 version 8, and I think we now can create a unique dipsy in at least second scenario. So this is not a question, I mean, I'm not recommending you to change your MPI to dipsy so that you can run reorg. But if your application, your need for the objects doesn't really need to be MPI, then changing to dipsy is going to benefit not just reorg, but a lot of the partition level independence also, right? So that's always a consideration whether you really need an MPI versus a dipsy. Okay, so outage. Yes, probably like every month or so, I'll get a PML saying that my reorg job timeout on retry, or my application timeout because the reorg is holding the string for too long. So in order for us to complete a switch, we have to create the objects. We have to what we could do a string all on the objects, creating both the readers and the writers, so that we can switch data sets, update the catalog and directory, and then finish the reorganization. Now the key is to how to break in. First of all, this is the key here, your IR log timeout interval. So this tells us how long your application is going to wait for a log before it times out with a -911, or in some other logs, my -904. So if you look at our outage window on the reorg utility, especially for serial change, a lot of time it consists of how long it takes to drain the object. And then after we drain the object, how long does it need us for us to perform the last log iteration to catch up with the last batch of changes your concurrent application made to the objects during the period. And then also the actual switching of the data set. When I mean that, it mostly consists of like catalog, OBD updates, to changing the index, the prefix information and so forth. So this is the formula you really need to remember, is that basically max RO is the time we spend on the last log iteration. Drain wait is the time we spend getting the drain. Switch phase overhead. This used to be significant in terms of seconds or minutes range, but we kind of restructured the switch phase back in version 10. And since then, we don't really see a lot of switch phase overhead unless you're reorganizing like thousands of partitions. So for the most part, a lot of times, switch phase overhead is like second or even less, a couple seconds around it. So this is not significant nowadays, but these are the free intervals that if the sum of these three exceeded your IR log timeout interval, then your application is going to start to get timeout. So you want to tune your reorg in such a way that you can specify those parameters to avoid to be lower than the IR log timeout interval. Reduce the time required to drain. I know there's no more outage window over the weekend to perform reorg anymore, but at least try to do your reorg at relative quieter time, maybe weekends, and then have it switch maybe in the middle of the night if possible. I know some of the customers in the past has been using the max RO defer utility so that you can run the reorg, maybe 2 days in advance. Let it kind of keep looping in the log phase to apply log records. And then when the time comes in the midnight of Saturday or something, issue the outer max RO utility so that the reorg is going to continue to drain the objects and to perform the switch. So this is kind of a manual way for you to do it. In version 11, we come up with a switch time parameter that kind of automated this procedure where you can specify the timestamp to tell reorg to drain at this interval, at this time. I cannot stress this enough. A lot of times we cannot break in is because we have non-behaving applications. Applications that do not compete frequently, applications that are bound to release the allocate, so they're with cursor hold, so they never let go of the claim they held against the object, and predominantly URL readers. A lot of people think that, I just have an ISO URL readers reading the object. Just let them run. It doesn't do any harm. But we need to create the reader also. So if you have any of those sitting around, reorg will never be able to finish. And actually, this is not just a reorg statement. A lot of the utility, you can say rebuild, load, or anything. They need to get exclusive control. We have to have those readers and writers get out of the way before the utility can proceed. I try to avoid saying this line. We did come up with some kind of false option back in version 10 so that as a last-ditch effort, if you absolutely need this reorg to proceed, go ahead and cancel your blocking claimers, your applications, in order for the reorg to complete. People either use this religiously or say, don't ever mention this option to me again because I need my application to stay up. I cannot afford any application get canceled. So it's documented. I'll let you be the judge whether you use it or not. The last log iteration. Max RO is basically tell to reorg create. If you specify max RO 5, and we estimate that will be less than or equal to 5 seconds to process the last batch of log records, then we'll go ahead and drain. In the past, a lot of people think, okay, maybe I'll specify max RO1 to give it the least interval so that we can make sure that we are below the RL log time value. The problem is if it's specified too low, remember our log estimation time is an estimate. So if we somehow we calculate it to be estimated to be bigger than that value, then your reorg will never finish. So you need to be careful about using that. And then it was version 10 when we come up with dataset level fresh copy. It's a good alternative, and it actually reduces the outage window of the reorg because during the last log iteration, if you have any log records to apply, we need to do what we call final incremental copy processing. We need to copy those the last batch of change pages from the shadow to the image copy dataset. So as usual, we need to scan for the space mail, look for the 30 pages, and copy. If you use fresh copy, you pretty much force all those logic away. Because the fresh copy is taken at the end of the switch phase, when everything is switched and done. And the copy happens in the hardware so fast that we don't need to scan the shadows at all. So fresh copy is a good alternative to reduce the incremental copy processing time during the reorg utility. And generally statement, I mean, it is mathematically true that if you reorg less partitions, less indexes and so forth, less data set basically, then it will be faster. With the switch phase restructure we did in version 10, I think that kind of went away a little bit as far as the overhead goes, but it's still true that there is some serial processing we still do. It was in version 11 we come up with the parallel drain processing so that if you reorg a part range of 1 to 5, before we'll try to drain part 1 first, part 2, part 3, and so forth serially. We changed the draining interval so that we will now drain partitions 1 and 5 concurrently at the same time. So I think that has decreased in terms of importance about how many partitions may reorg. And generally speaking, that is governed by your resource. How much density you can afford, how long is the runtime that you can allow this reorg to run. So what I went to reorg,
For the switch time, if you specify, say 3 in the morning or whatever, is there kind of like a 10-minute prior, 10-minute after kind of window that it says, like, so you don't have to get it right on the dime of when it's going to actually switch? Does it have to be triable at the switch time?
Okay. So the question is, when you specify the switch time, does the switch happens exactly at the time you specify, whether it's just like within a certain delta? Right. So first of all, the logic is exact. So the way we do is that when we're looking for in the log iterations, we'll detect the current timestamp. We'll compare your current timestamp to the time you specify in the switch time. If it's exceeded that, then we'll go ahead and drain. And when we drain, we still honor all your retry parameters, retry delay, and so forth. So it's just basically a way for you to control when do you want to start draining the object, when do you want to start in the retry processing. Okay. Mm-hmm. So I mean, to me, there's no really right or wrong answer to when do you need to reorg. I mean, a lot of times, if you're dealing with small, medium-sized objects and you're unsure whether to perform reorg or not, go ahead and run it if it doesn't hurt you. A lot of times it's those large objects that we need to deal with, that we need to pay attention to. But nonetheless, we have a lot of tooling in place now in Db2 automation tools or equivalent outside, or even in our own store procedure, DSN ACCOX, where we look at RTS statistics to recommend reorg based on certain threshold, and which you can tailor to your shop needs. Compression, the need for reorg to recompress data is still there. But for the initial compression, when you have a new partition, whether you need to run the reorg to compress the partition will be a different value, because now we have compression on insert. And over the years, we also have allowed load to copy a dictionary from one partition of a table space to another, for capacity planning, right? You know you need to add a new partition, you want the rows to start compressing right away when you insert into it, so you can always use things like load copy dictionary to prime your partition, if you would. And then I keep mentioning about clustering. It's hard for you to tell whether clustering is important to you or not. So over the years, we introduced a statistics column in RTS to tell you whether how many times clustering sensitive query has been run on your table. So you kind of keep track over time, right? Okay, is clustering really important or not based on the RTS value? Now, real index versus rebuild index is kind of interesting because a lot of times users say, okay, is it better to reorder the index or rebuild the index? To me, the reorg utility is not an agent for you to fix your broken data. If really you have a broken index, it's missing some keys, or there's some index leaf page inconsistency, or off-inner page or something, you have to run the rebuild index to rebuild the index, no question asked. But if you have a healthy object, you can unload the keys from perfectly fine, then you can choose between reorg index or rebuild index. So before version 9, it's kind of simple. If you want availability, run reorg. Otherwise, run rebuild to rebuild it. With version 9, we come up with rebuild index server change. So that kind of leverage the availability a little bit. If you have a non-unique index that is not urgent, I mean, you want to build it so your application can start using it, but no one has been using it for a while. I mean, before that, you can always run rebuild index server change now to rebuild the index. Before, you have to run a real tablespace server change to do that, and that's expensive, right? Because you're reorganizing all the data rows and all the other indexes. So I think that for this niche scenario for creation of a new non-unique index, I think that's a pretty helpful feature to be using. If that still is a concern for you, rebuild is also the way to go, because right now our rebuild is kind of like it doesn't use the shadows. It just kind of rebuild the index within the data set itself. So if that still is a concern, rebuild index can also address that. Especially when I mentioned earlier, when reorg index is run, we don't sort the index keys. We just kind of unload the keys in key order from 1 to n. So in some cases, when the index is disorganized, rebuild can actually be faster than reorg index. So down to the last few slides. Hopefully I can finish in time. I don't know what time it is right now. So best practices in terms of availability. First of all, server change, no question asked, right? It costs a little bit more overhead because, as you probably know, we need to build a mapping index, we need to do log apply and so forth. But if availability is important to you, you have to go with server change. My only advice is that a lot of times I see people have reorg jobs that abandon in the log phase or the switch phase for whatever reasons, right? It could be a code error logic or some kind of unavailable catalog access or something. And if they don't turn the utility right away, then the object will probably be left in UT, and your application is trying to access the object is going to get resource unavailable -904 because of the restrictive debug steps. So I think a lot of best practices now is that a lot of shops now will have the automatic turn util issue whenever their utility job failed or abandoned to make sure that they can throw away everything and then resubmit the job later on. And especially when real server change is not restartable. It was back in version 11 we changed the default to make more sense. Please always use string all. We see too many undetected deadlock situations with string writers. String all means that tell reorg to string the readers and the writers at the same time. String writers tell reorg to string the writer first, followed by the readers. But you know what? The application likes to claim as a reader first, and then upgrade it to a write claimer. So that you have a deadlock situation there if you're doing the other way around. Time of term for cleanup. This is kind of the formula I mentioned before. So the two primary quantities considered string rate and the max-RO. Retry would be a good idea to do more than the default retry number of 6. And if you really need to control when do you perform a switch, then use the max-RO scenario. So they can control the exact time or use a switch type parameter to control the draining window. Now for performance. First of all, try to stay current in maintenance. Over the years, we ship a lot of changes that can be enabled without even changing the JCL jobs. For example, things like zip offload. Recently, well, not recently now, within the past year and a half, we zip offloaded the reload phase of load and reorg. As an end user, you don't need to do any JCL changes. All you need to do is to apply the PDF. And then if your system is zip eligible, we'll start zip offloading those utilities right away. So try to stay current in maintenance. For reorg discard, if you need, like say, if you need to discard the data over SQL delete, and you have variable length data in your table, Well, it will be better for you not to ask us to pad out the data before writing out the discard data set. If you need to pad out the data, it increases the code path length, increases the size of the records being discarded, and just costs more CPU, basically. Keep dictionary already mentioned, sort data node also mentioned also. And the other main consideration is to enable parallelism. For the most part, the reorg utility will automatically determine what is the optimal degree of parallelism to unload and reload your data partitions to perform parallel index build. But in order for it to do it, it has to have enough system resources and so forth. So on the fly, we calculate the amount of virtual memory available, number of CPU, number of central processor units you have. Generally speaking, if you specify enough region size on your JCL, and you didn't do anything on the DD card side to block us from running parallelism, we would go parallel whenever possible. So those are some of the data sets that you need to watch out for. Okay, I put in this slide because just in case I went off, I finished early or PBG is a good topic for you guys. PBG has really been an interesting tablespace type for Reorg to deal with. The whole concept about being able to grow a partition on the fly when the prefix partition got filled up is really a new concept. So reorg has been a problem with PBG because a lot of people cannot afford to reorg the entire PBG table space due to space constraint or whatever reason. So they went part level reorg. Well, in the past, at least before version 12, if you went part level reorg, we need to make sure that all the data records fit back into your original partitions. Otherwise, reorg cannot grow a new partition to accommodate the spillage on a part level reorg. Only a whole table space reorg could create a brand new partition to kind of overspill the data. So we come up with tricks like this, like CPAR, like reorg ignore free space. Okay, make use of every ounce of free space or % free page that you have on the table space to try to reload the data back into. But even then, especially when you have schema changes, you add a new column, your compression ratio changes. A lot of times, those part level reorg can still fail. Good news is that in version 12, we finally fixed that problem that existed since version 9. So that when you run a part level reorg, and lo and behold, we run out of space on the original partition, we will now create a brand new partition at the end of the PPG to move the rows into. So at least we avoid the failure scenario where we are not able to reload the data back in due to a spaceful condition. One thing you do want to consider is that if clustering is important to you and you tend to run part level reorg, you understand that your MPI is the only index allowed on the PPG is an MPI. So if you really want to regain clustering, you can't really regain it by doing part level reorg. You have to reorg the entire PPG table space in order for us to put everything into the clustering MPI ordering. So that's one thing to watch out for. And then empty partitions, we give a CPARM and then on version 12 a keyword option for you to tell reorg. Okay, your PPG used to be big. We finally shrunk it down back to only the first few partitions are occupied now. Now you have a bunch of trailing empty partitions at the end of the table space. You don't want them to stick around even though they are like small and stuff because it's hard to manage. So we all have the option now to delete those empty PPG partitions. The reason that we still have the CPAR and the keyword is because we still don't support point-in-time recovery across the reorg that drop those empty PPG partitions. But if you don't really need point-in-time recovery and you can afford it, then there's a way for you to tidy up by getting rid of those empty PPG partitions at the end. So this is my last slide. So where do we stand in terms of reorganization? Like I said, I mean, reorg is really a powerful tool. The ability to move the data around to different containers and transform them, morph it. It's really a powerful tool that you can use to apply schema changes with full availability. So I fully expect that to continue. I think Craig talked about PBR2, or we'll talk about PBR2 in the coming days, right? So one way for you to get to PBR2, guess what? You should run a reorg. The most natural way for you to convert from a classic partition to a PBR2, for example. Where do we stand, though? I mean, there are those challenges I talk about. So in terms of improvement to be making a reorg, if you look at the reorg menu now, it probably consists of 50 to 100 keywords, all different varieties. And I know the skill set of understanding all those jobs is hard on the customer side. So a lot of times we want to simplify the usage. things, for example, things about, we talk about those string weights and method parameters. I mean, ideally speaking, it would be nice for Reorg to kind of automatically figure it out on the fly without you have to worry about it. We'll just look at what the RML log time interval is and then kind of come up with a default value that makes sense for you. So intelligent default, being able to run out of the gate with the least user tuning would be what we are striving for in the future. Scalability, right? Small table spaces, tens of partitions, thousands of rows, not a problem. Problem is when you have thousands of partitions, terabytes of data, and you need to break the reorg. You cannot afford the table space reorg, and you need to make sure that you can run reorg manageably, whether at the partition level or at the table space level. So there are still a lot of requirements on that front, especially for schema changes, since you require a table space level reorg today. So this is some of the things we still need to tackle and resolve. Performance, like I said, zip. For CPU, we have been going to zip route. For parallelism, we keep thinking about what kind of other parallelism we can drive to reduce your elapsed times. Right now, the lowest granularity of parallelism is at partition level. But can we do something within a partition? Can we build an MPI using multiple tests or something, right? So those are some of the things we're looking to do. Reduce resource consumptions. A lot of times it's a seesaw. You want to optimize it, you want to use the least amount of density, but at the sacrifice of using more memory. So it's kind of like a seesaw back and forth about which is more important to you. We don't want to go all memory. I mean, I can allocate a mapping index in memory works well for a 1,000-row table, but doesn't work so well on a terabyte table, right? So it's a seesaw between what is the trade-off and how do we best optimize it. Exploitation of new hardware, flash copy has really come along nice in terms of reducing some of the complexity and the over-processing cost. You'll probably see more of the hardware dependency, compression, especially in version 12. Further down the road, we'll have more improvement in that area. And then generally speaking, the reorg represents a high availability solution. So today, if you have any restrictions or DDL type of changes that put your objects into review pending, recover pending, reorg pending, you can surely bet those will gradually go away over time. We want to make sure that everything you do is fully online now and can be materialized without disrupting your applications. So really, to me, reorg stands for full availability online changes, right? So those are the areas that we'll continue to strive for and reduce any restrictions and availability that you have currently today. So with that said, that's all I have. Yep.
Can you comment on if a multi-table segment is really helping out the UTI?
Yep, so as I mentioned, we currently support a path for a single table, non-partition table space to PBG for simple table space and semi table space. For multi-table, we don't have a conversion route for you to convert that multi-table table space into X number of PBG table spaces, for example. It is high on our requirement list. As a matter of fact, most of you know Ka-Chun Roberts. And I just talked to him yesterday about, okay, we have another vote on the RFD to provide a way for you to online alter, convert a multi-table table space to disjoint PBG table spaces. So let's just say that will probably be coming and one of the highest requirements that we have going down the road. And the way we want to strive for is to allow you to run a reorg, for example, to either fan out that non-partition multi-table table space to N PBG table spaces, or allow you to stage it to reorg and only pull out one table at a time. So those are high-level ideas that we're looking into.
Didn't the ENFM reorgs do that?
Yeah, the ENFM.
I'm sorry, I had to do
Yeah, the ENFM reorgs are several reference, John. Don't you remember that?
Or just make it someone else's problem. Tell the database people to allow multi-table universal table spaces.
We have considered that. We have considered multi-table PBG. Let's just say that they didn't go too far. Okay, yeah. Okay, yeah. Okay? Any other questions? Okay, if not, thank you very much.
Because we share. Because we share.